Hello everyone. In today's lecture, we are going to discuss about the ARM development flow cycle. So many development tools or chains available for ARM microcontrollers. The majority of them, most of the tools support C and assembly language. Embedded projects can be developed either using C or assembly language or even a mixture of both. So when we use a C, how the programs are developed, how it is being downloaded to the board in the case of ARM. We are going to discuss it. And also, if we write an assembly language program, what happens? So this is the typical program generation flow. If you see here we have the C source code. Either we can have C source code or we can have assembly language source code. If we have a C source code, then it will be sent to, we have to use a C compiler. So will be combined to an through a compiler using an object file, or using if it is an assembly language program, assemblers has to be used, which converts the low C or assembly or whatever language into object files, and then the linker file is used to convert this object files into a hex file, executable file, right? So if the device wants to execute it, then it needs a code in an executable format. Normally for ARM we used hex format, right? So any executable formats we'll be using, and then it can go for either for testing by simulation, or we can download it to a hardware device, and then we can test through hardware. So this is the process, overall process. The C compiler, it compiles the C program code into object files, and then generates the executable program file using the linker. Suppose in the case of GCC, that is GNU C compilers, the compile and link stage are often merged into single step. So projects that use assembly language program uses assembler. So that's what we have discussed already. Besides the program code, the object files and the executable image may also contain various debug informations. Depending on the development tool, it is possible to specify the memory layout for the linker using line options. After executable image is generated, it can be tested by downloading it to a flash memory or internal RAM of the microcontroller. Most development suites some come with user-friendly integrated development environments. When using together with in-circuit debugger, a debugger probe, or USB JTAG adapter, JTAG is Joint Test Action Group, projects can be created and then build the applications and download the embedded applications to the microcontroller. So when we are downloading this is the steps what takes place. So what are the steps involved? So a project is created. We'll be selecting the device which we are going to use. Then the programs has to be added. Then it has to be compiled, it has to be built. Then if any debug, any errors or anything is there, then it has to be decoded. And then the application, it can be done to the development board. So this is the basic flow cycle. In many cases, in-circuit debugger is needed to connect the debug host to the target board. The flash programming function can be carried out by the debugger software in the development suite, or in some cases by a flash programming utility downloadable downloadable from a microcontroller vendor website. The program can then be tested by running it on a microcontroller and by connecting the debugger to the microcontroller. The program execution can be controlled and the operations can also be observed. All these actions can be carried out using the debug interface of the Cortex M0. And this is how the debug interface is been connected to Cortex M0. So see, here we have the flash programming utility from the controller vendor. Then we have the development suite here, then the testing. Then after through a JTAG adapter, it's been downloaded to the ARM Cortex M0. Here we are discussing about ARM Cortex M0, or if any other processors, then depending on that we'll be using. What is the function of linker? We need an assessment and differentiate compiler and assembler. I hope the session was useful. Thank you.